Hi there, everyone. I just wanted to go over and talk about how you're going to do this simulation for moving man, this time versus distance versus time graphs. So I gave a little bit of an explanation in our weekly agenda video, but I wanted to give a more specific explanation. And the first thing that we'll look at is that we know that graphing is a way to communicate. And in this activity, you are going to really learn what graphs mean and how to hopefully better interpret graphs, especially when we're talking about position between time and distance. And so we are going to develop this general knowledge of these distance time graphs. And by the end of this, you should be able to graph when a person is standing still or if there's no motion or no change of position. You should also be able to graph and know what a graph looks like when a person is moving away from an observer, when they're moving towards the observer. And also you should know how different speeds on a graph appear. So we're going to be using this site here. This is a simulation site, this PHET. So go ahead and click on that, and it'll take a second to load, and it'll take you directly to the simulation called The Moving Man. And as we start here, we can see it starts on the introduction tab, and we are just actually going to go ahead and click on the charts tab. And we can see we have a man up here, and then we have 3 different graphs that could possibly be made. We don't need all 3 of those. The only graph that we are concerned about right now is this position graph. So we're going to go ahead and close these other graphs out by clicking on the minus. And so what we have here is just the position graph. So step 1 says getting started. After moving man is open, click on the blue tab called charts. That's what I just talked you through. And click and then leave the position graph open. And you're going to close the velocity and acceleration graph. So we've already done that, and yep, our screen looks like screen 1 right here. So then the second part is making observations, and it says by either clicking on the man or the slider, cause the man to move back and forth and observe what shows up on the graph. And then you can use a clear button to erase the graphs and collect new information. So you can see if I click the slider here, I can change the position of my man. Okay, if I go this way in the positive direction, I'm going closer to the house. If I go in the negative position, I'm going closer to the tree. I can also click directly on the man and I can move him in those directions. And right now what you're seeing down below in the graph is a timer started, and it's drawing the graph for me of what's going on. So I'm going to put him back here, and then I can stop the time by hitting pause, and it recorded that information. So I would suggest take, I don't know, just 1 to 2 minutes to kind of just get used to moving your guy back and forth, kind of just see what happens with as you move them in certain directions at certain speeds, what's going on and how it's creating this graph. So if I want to clear this out, all I need to do is hit clear down here, and it clears it so it's ready to go. So the next part says using the axis provided below, so right over here, make sketches of the graphs that is produced by each action described next to each axis. So here's the description. So we're going to do this one together, and below you have some others that you're going to work on your own. But here's the description. It says a man moving from 10 meters to, or I'm sorry, 0 meters to 10 meters at a slow, steady pace. So that means the pace that the man would be walking is slow and steady. It goes the same speed the whole time from 0 to 10. And so he's at 0 right now, and I'm going to move him from here to here at a slow, steady pace. So I'm going to click on him, and we're just going to move at a slow, steady pace. We made it. So I'm going to go ahead and pause it. And you can see it took a period of 6 seconds for him to travel, because as our timer was going here, we can see when we started here was 0, and this is where he was at 2 seconds. At 4 seconds, he was just over 5 meters, and at 6 seconds, he had reached 10 meters. And so we have this basically straight diagonal line showing that his speed was the same. So now I need to draw that on my graph here. So I will hit my drawing and choose the color I want. And I will draw my graph just like that. And if you want to put in your time, you can as well. So we reached 10 meters at 6 seconds. So we had 2 seconds and 4 seconds. And then we stopped. And since he stopped moving there, we noticed that his line actually kind of went straight a little bit. But we weren't really too worried about this right here, because we were mainly looking for a slow, steady pace traveling. Okay. So that's what you're going to do. So you're going to read through these others, and you're going to read the description and do that, and then look at the graph and draw the graph. Let's do one more together. Let's do this one. Here it says a man moving from 0 meters to 5 meters at a slow, steady pace, then moving back to 0 meters at a slow, steady pace. Okay, so he's going from 0 to 5, and then immediately 5 to 0, but it's both times he's moving at a slow, steady pace. So I'm going to clear this, and I'm going to use this to put him at 0 here, or really close to 0. So I'm going to move him from at a slow, steady pace to 5 meters, which is right here. And then he's going to go back at a slow, steady pace back to 0. So let's see how this graph turns out. So there we're at 3 meters and 4 meters and 5 meters. And now we're going to go back. Slow, steady pace. So this time we have a diagonal line up and then a diagonal line down. So looks like I might have gone a little bit faster here because even though it's a negative decline, it's a little bit steeper. So that would indicate I was maybe traveling a little bit faster, although I tried to keep it as slow as possible. So I'm going to go over here and I'm going to draw this on. So slow and steady to 5, and then slow and steady back down to 0. And if we look at my time, it looks like we hit 5 meters at 4, just about 4. And then, well, I must have gone faster because I only got up to about 7 there. But you can put your, again, you can put your seconds on there. So if this was a 4 seconds. If I had gone the same pace, the exact same pace, this probably would have ended up at 8 seconds here. So we draw that on. Okay, after you finish these 6, then down here, you're going to kind of do the opposite. You're going to describe what you've learned. So it says apply what you've learned. Look at the graph below, and for the different parts of the graph that are marked, write a statement about what is happening. Be sure to include the directions of motion and the speed of the motion. So we are starting here at 0, and we can see along here is the time. So we have 2, 4, 6, 8. So those are seconds. So from 0 to 2, we see us not a pretty flat line, but for 2 seconds, it went to a slow pace, and he was traveling towards the house. So then here, this is what you would type that in here in this description box. So for 2 seconds, the man traveled at a slow pace toward the house. And it looks like, it looks like you got halfway to 5 meters. So that would probably be about 2 point, let's see, 2.5 meters. So 2 seconds, the man traveled at a slow pace toward the house for 2.5 meters. And so then you'll go through and kind of describe each of these sections, what happened during those times. And so I would go back and refer to the different graphs that you have drawn here, and that will kind of give you an explanation. But again, don't just look at the don't forget to look at the time, how long they traveled, and like the also look at the steepness of the line, how steep the line is. If it is not very steep, it's like a slow pace. If it's a really steep line, it usually means it means it was a faster pace. And and also talk about the distance as well. So I hope this helps you out, and If you have questions, please email your teacher. Thanks so much.